we've got filaments. We've got a sunspot nestled in the middle of a coronal hole. Highly active sunspot setting, making the likelihood of possibly an X-class flare very high. Those wavelengths you're looking at there, those are 211 plus 171 angstroms from the SDO, and thanks for tuning in to the Daily Space Weather. Just the most comprehensive space weather and most detailed imagery of the sun you'll find anywhere on the internet. We're going to see a reduction in sunspot number today, as we're seeing two regions setting, one in the north and one in the south. Interestingly, we've seen the radio flux rise. We'll talk about that momentarily. Most of these sunspots have been largely stable here. A little bit of movement in the umbre here with sunspot 3089, I believe is the name of that group in the southeast. Here's your colorized magnetogram. A little bit of growth behind this group up here as well, but generally stable here. Here's 171 plus colorized magnetogram. And I believe we've seen a volcanic downtick. Let's do a brief volcano rundown. Abiko continues to erupt. 7,000 foot ash plume from Abiko. 7,000 foot ash plume from Subanose Jima. Dakono exploding. Flight level 100. 10,000 foot ash plume over Halmahera from Dakono. Fuego exploding. Flight level 150 over Guatemala. Nevado del Ruiz, 20,000 foot ash plume. Nevado del Ruiz is exploding. Flight level 200 over Colombia. Sangay in Ecuador exploding. Flight level 200 from Sangay. Flight level 150 from Revenador. Sangay and Revenador both exploding. And last but not least, Sabancaya exploding. Flight level 240. It's a 24,000 foot ash plume. Don't pole vault the caldera. No major quakes over the past 24 hours. There's your 90-day bar graph. Only one 7 magnitude quake in the past 90 days. A minor uptick here in seismic activity. No large quakes. Only some in the 5 magnitude range, like this 5.2 at the Philippines. I think the largest was a 5.3. That 5.3 near the Izu Islands, near Japan. And there was also a 5.1 near the Loyalty Islands there, north of New Zealand and east of Australia. So again, no major quakes here. Most of those quakes there around the West Pacific. Some on the west coast of South America as well. And getting back to space, we've got some likely coronal mass ejection to hit Earth in the midst of a coronal hole high-speed stream, which we are seeing now. We'll get to that as well. Here's the last 24 hours from El Sol in ionized helium. And we had a couple M-class flares in the past 24 hours. We'll talk about that momentarily as well. Radio flux has come up to 128 solar flux units. We should see this dip today unless new sunspots form. So yeah, 128 solar flux units is the new 10.7 centimeter radio flux number, represented by this black line. That's the 1 year graph. You can look at it yourself if you like at solon.info. Space Weather Enthusiast dashboard here, looking at NOAA's forecast. NOAA forecasting geomagnetic storm and geomagnetic unrest into Tuesday morning. So expecting the majority of it tonight into tomorrow morning. We may see some aurora in Pennsylvania. It's possible once again, depending on how directly those CME strikes are. Again, there is a coronal hole high-speed stream already here. Coronal mass ejection expected to strike late tonight or early tomorrow, universal time. Next, looking at Earth's magnetic moment from space. It is a time when we've got a coronal hole high-speed stream. So we've got a little bit high pressure here at the moment, but it's a fairly mild coronal hole wind stream so far. That's the last 4 hours. And here are ground magnetic perturbations. We show it daily on the channel to give you a complete look of the space weather, earth weather environment. Some ground magnetic perturbations happening there. There may have been some aurora in Canada. And drop us a line on Twitter or Instagram if you've got some photos or videos of that. KP index here only at 2. It did briefly make it into geomagnetic unrest conditions yesterday as a result of a magnetic field situation. KP2, planetary K index, a measurement of global geomagnetism. And here's your real-time solar wind. We saw this brief period of strong field with a strong negative BZ component. That's the red line there. That's the vertical component of the magnetic field. So we saw a field of 13 nanotesla with a negative 6. It got all the way to about negative 8 BZ, so that was enough to spark some geomagnetic unrest. And as forecast, the solar wind density has dropped off and the solar wind velocity has come up. Current conditions are solar wind density about 8 protons per cubic centimeter, solar wind velocity 488 kilometers per second. Again, a fairly mild coronal hole high-speed stream. GOES magnetometers here showing some sawtooth readings. That's a normal thing you would expect when there's some high-speed plasma showing up from that coronal hole high-speed stream. Let's look at some more magnetic data. Here's the Gong 2, and we do have some North Pole-oriented coronal holes rotating in here, and the North Pole current sheet likely will be here by tomorrow. So this is the North Pole current sheet shown here in green. Here's a South Pole current sheet shown in red. Earth will be leaving the South Pole current sheet here probably later today, but I would certainly say by tomorrow. North Pole current sheet should be here. And here's our line of sight plot. Again, we've got some North Pole oriented coronal holes coming in, and let's take a look at those. There you can see those red South Pole oriented coronal holes rotating through, and some North Pole oriented ones rotating in. They are trans-equatorial in nature. They should get a little more well-defined as they rotate in. And here's the 211 angstroms wavelength. They're actually looking quite well-defined already over here, which means they are quite significant coronal holes. Again, we put up a video yesterday, some close-ups of this area down here, this sunspot inside a coronal hole. I haven't heard anybody say they've ever seen that before. Also great imagery there of setting sunspot 3088 there to your screen right. But that sunspot within a coronal hole, I don't remember ever seeing that, and I haven't heard anybody say they've seen it either. And let's move to sunspots. Before we get into that, let's pause for station identification. Welcome to the Smash News Network, least busted name in news. And thanks for leaving a comment, Mama D1K. And thanks for leaving a comment, Smasho Staff. So likelihood of major flares very high here as sunspot 3088 approaches the limb. Sunspots are more likely to produce large flares at the limb than they are in the center of the solar disk. Keep in mind also sunspot 3089 has been producing major flares, but I'd say the most likely spot to see another M or even an X-class flare would be from sunspot 3088. 3085 also more likely to produce some flares now, as it does have a trailing umbra. So we'll keep an eye on the whole thing. And let's take a look at some sunspots. Here's the SDO continuum imagery. And let's zoom in. That's not enough detail. There's a little closer view. We're going to take a very close view of the setting sunspot 3088. There's the magnetogram. And here's the continuum imagery. It's been an interesting sunspot. We hope it rises again in about 2 weeks. And here it is in 171 angstroms. More spectacular imagery there from the SDO, the Solar Dynamics Observatory. And we've got an inordinate amount of solar imagery today, so let's continue on. Again, we saw, let's see, 1, 2, 3, 4. We've seen about 4 or 5 M-class flares since yesterday's video. So quite a bit of activity. Let's take a look at the sun in 94 angstroms. This area up here, not yet a sunspot, at least when we did show prep. No umbre visible in the northeast. Let's get a little closer. And multiple M-class flares showing up there. I think they may all be from sunspot 3088. The areas to its east have calmed down. Here's 131 angstroms, the same viewpoint. Good stuff. And we do have relativistic particles showing up, radial blackouts. We'll get to it. First, you're all invited to follow us on Twitter. Yeah, I've created some new terms. You want to read about those, head to twitter.com/smashomash. You can find our links there and so on. Thanks to our followers over there on Twitter. You've actually made the platform interesting. As Facebook dies and goes down the drain, Twitter remains interesting no matter who is banned or who is still allowed to post stuff. Twitter.com/smashomash. If you want to support the channel via subscription services, become a member of the Smash Team. The Smash Team Gold and Silver level members are increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. So thanks to the Smash Team, you're providing some incentive since we're paid just this side of nothing to put the videos on YouTube. Smashomash.com/Smash Team is our subscription services site. We built our own to have superior capabilities. If you want to have superior capabilities for your health, become a member of SureMed, which isn't insurance at all. It's a membership in a nonprofit organization known as the American Better Health Organization. Improve your health through services like doctors by phone, that's thrown in for free, counselors by phone, virtual veterinarians, dental discounts by Aetna Dental Access, vision discounts. Save a ton of cash on things like eye exams, frames, LASIK surgery, etc. SureMed. Improve your health through a membership to the American Better Health Organization. I'm a member, and I can certainly say that I've used the services. It's pretty hard to get me to make a medical claim, but I've used the services nonetheless. Now, if you look at our Redbubble link, you'll notice that our products are organized in order of best-selling on our link. Our best-selling product is not to be mentioned. Because there are certain words that we can and can't say because reasons. Anyway, there's the list of best-selling. Today's featured product is not our best-selling product. It's our third best-selling product. Because part of the reason we make these videos is to Mensa. Yeah, make Earth not suck again. It's up to you. We realized it was up to us to make space weather not suck again. since there's a bunch of crap about space weather. And we regularly get references to watch certain channels and so on, because we're told, oh, hey, go learn something about space weather by watching some really popular channel that has its head so far up that it believes the galaxy is going to make the sun blow up, which is going to kill you. Anyway, we realize that there's a huge hole, almost like a black hole, sucking people in to a pile of Faucially stated nonsense. So we've decided to make our channel and make Earth not suck again, since there have been Herculean efforts to make Earth suck again and get people to believe nonsense, and through grifting and other crap. A lot of space weather channels out there on YouTube saying a bunch of stuff that just is patently untrue. Here at the Smash News Network, Least Busted Name of News, we don't do that. We consider it our responsibility to make Earth not suck again, and you should consider it yours as well. Think global, act local, and make Earth not suck again. Pick up some merch, give Smash staff a raise. You can find links below the video and on the homepage at smashomash.com. And welcome to the Neo-Renaissance. Let's talk about relativistic particles. Yes, relativistic particles. Sometimes they're associated with solar flares, and they do things like cause radio blackouts, but don't give us a channel blackout, and drop us a like, subscribe if you're new to the channel. Press that share button if you're an influencer especially. Drop us a line. We'll be more than happy to do an interview. And let's take a look at the latest proton event. So there you go, the significant proton event happening there, causing significant polar radio blackouts. Yes, when protons are decelerated by the atmosphere, they emit radiation, and they cause the D layer of the ionosphere to be modulated, which causes radio signals to fly out into space instead of being refracted back to Earth. So there's our proton event. It is subsiding, but we still do have ongoing polar radio blackouts. So there you go. There is your D-layer attenuation happening. And there you can see the solar flares around the equatorial level. Solar flares, those are photons. Those cause equatorial radio blackouts and brownouts. Protons, they cause polar radio blackouts and brownouts. So just a great demonstration there of how the solar protons they're sent to the poles because of Earth's field-aligned currents. And you can see the most radio blackouts there showing up in the north, as it is indeed summertime in the northern hemisphere. So that's the, by the way, if you're wondering what that is the deabsorption region predictions, showing you the most likely spots for radio blackouts there and the frequency of the signal that is expected to be blacked out. And we're always interested in what's going on above head, so we show a star chart daily. Coming at you a little later than normal today. This star chart is from in-the-sky.org. Feel free to make your own star chart by hitting up the website, putting in your location. We like to face ours to the south, since that's where the ecliptic is located. Mars, up there near the apex of its traversing of the ecliptic. Next, the solar system forecast, and I would remind you all that the planets are not going to kill you either. Here's your 1-week solar system forecast. Oh my God, Earth is going to be moving past Jupiter soon, and guess what's going to happen? Absolutely nothing. Here's where things will be in a week. We will be at a gibbous waxing moon by September 4th. And let's take a look at some coronagraphs. Here's yesterday's coronagraph, and it looks like there's a halo there. There's a high-speed CME. You can see that halo being shown over here on the left side, this computer-aided graphic. And it's pretty diffuse. Most of that ejecta is certainly off to the west. But in any case, that's what it's showing. That's yesterday's coronagraph imagery from George Mason University. Here is today's coronagraph imagery so far. And we brought back some more Stereo A and some more Soho Lasco C3 just to sort of take a look at this again, because we really don't see very much ejecta all around the solar disk. So this may be a bit of a dud, but it is a high-speed CME. You can see some of that is somewhat earthly directed there. Some missing data there on Stereo A. Not a lot going on since then, though. So anyway, that's the CME likely to strike. Expecting it to be a glancing blow. Let's just play that through. So we may see aurora tonight. That is Sunday, August 28th into the morning, Monday, August 29th. This is the last 24 hours of coronagraph imagery. Again, things pretty calm here in the last 24 hours. Some ejecta coming out, but no major CMEs there. We do still have quite a few filaments. This is the ground-based solar observatory at El Teide, Spain. You can see lots of filaments in the north and some in the south as well. So the likelihood of additional coronal mass ejections quite high. The likelihood of major solar flares really, really high. Here's the last about 2.5 hours of GO16 SUVI images. Huge prominence up here in the northeast as well as in the southeast. And we're going to keep an eye on sunspot 3088. That is the most likely spot to see major activity. By the way, we streamed it 24 hours on the 26th. We caught a bunch of flares there. We streamed another 17 hours yesterday on the Twitch channel, twitch.tv/smashomash. Go install the mobile app. Follow us over there. You'll see when we go live. Here's the last 24 hours in 171 angstroms, our house favorite wavelength. Some plasma reorientation happening in this area. We'll let that play through a second time for you. Right there you can see some plasma reorienting. It did not eject. It splashed back down toward the chromosphere. Now we're moving into bonus features, and we don't have any charging hazards at the moment for satellites. Things are looking like clear sailing up there for satellites. And we see a dip in the electron flux, as we do during coronal hole high-speed streams. That's the last 3 days of GO16 and GO17 radiological measurements from their geosynchronous near-equatorial orbits. They measure the electron flux at the F-flare using radiography. Here's the relativistic forecast model. And we're expecting a further dip. I would tend to agree with that forecast. No arguments there. Here's the one-year chart from Solon.info. Wow, and we got to the highest levels that we've seen here all year. That must have been this spike right here. So that was the highest electron flux we've seen all year there, just a couple days ago. Next, we'll look at the F-flare of the ionosphere and the total electron content. The F-flare located at 300 kilometers of altitude. Here's the vibrational frequency therein. This data courtesy Australian Government Bureau of Meteorology. Let that play through in its entirety. And we'll show you the anomalygram. Here's the anomalygram. Quite a few high-frequency anomalies showing up there in blue. Some low-frequency anomalies in places like North America and the Central Pacific showing up in red. So a little bit of variation happening there in the ionosphere. Significant low-frequency anomalies around Hawaii. There's the latest image, 11:30 Universal Time ionogram, 11:30 Universal Time anomalygram. And here's the total electron content forecast. Don't be surprised to see some anomalies here, as we regularly do during coronal hole high-speed streams. The total electron content is showing all the free electrons in between your GPS satellite located at about 12,500 miles of altitude on your GPS handset, and you can indeed see some anomalous electrons showing up here around the Southern Ocean. Again, that's fairly normal during coronal hole high-speed streams. If you want to follow the total electron content yourself to see where GPS errors are most likely, head to the Space Weather Prediction Center, and you'll be able to see it. When your GPS satellite must communicate through a lot of free electrons, the signal can be refracted, causing GPS errors of thousands of miles. Let's bring up the latest intensitygram. There's a refresh, and there is the latest magnetogram. First of all, let's take a look at this area to see that it is not a sunspot. And let's take a look at this area. Since it's about to set, there's sunspot 3088. We'll have to say goodbye to that one. Again, the likelihood of major flares, even an X-class flare, certainly still there. There's your rock back. And we're going to bring up yesterday and today's data here in 3 wavelengths, 211, 304, and 171. And that ends the space weather portion of today's video. It's time to move to the realm of meteorology, so let's blast through some of that. It's always noon somewhere, and at the moment, it's around noontime over Africa. So there is that's the UV index, right? On this side of the planet, the Central Pacific, it is around midnight. On the opposite side of the world, it is around noontime. And if you're wondering why there's a lack of UV right in this area, well, there is a reason. And you can figure it out by looking at total cloud water, for example. It's because it's cloudy in those areas. And let's move to the realm of wind. I don't know why the wind map is battling me lately. Let's press refresh. There we go. All right, so here are the jet streams of the eastern world. We show it daily to give folks a global view of weather patterns. If you had to use only one factor in looking at global weather patterns, the jet stream would be the one to look at. That's the 250 hectopascal winds, a specific pressure band which shows us where the jet stream is located. Here's the surface wind scenario for the eastern world. Surface wind scenario for the western world, the Americas. Jet streams for our side of the planet. Some funky patterns happening here and some backward jet stream over the Central Pacific. A 180-degree bend there, and a powerful upper-level anticyclone rotating counterclockwise right there. Also a weird convergence happening here over southern South America. And some warm air blowing up into the Great Lakes region there. Here are the jet streams of the central world. Jet stream here blowing backward over the Indian Ocean and over northern Africa. Here are the surface winds, and let's blast through the rest of our meteorology segment. Here's your weather.gov map. If you're wondering what these special weather statements are, that's fog up in Maine. If your county's lit, click your county. Some high winds around Alaska and Hawaii's coastlines. Those are flash flood warnings, by the way, in Mississippi. Here's your total accumulated precipitation forecast based on the GFS model for the next 72 hours. Precipitation total shown here in inches. Again, that's your 72-hour GFS total accumulated precipitation forecast. Some heavy rains forecasted there for parts of Texas and Oklahoma and southern Florida and southern Indiana. And let's continue on. Here's your pressure map from Witty.com. They've got a great mobile app. Check it out. Let's show the global pressure scenario. Low pressure dominating India and Saudi Arabia. Large anticyclone here, south of the western Aleutians. And a high pressure environment over southern South America. Clear skies likely over this region. Strong low pressure there over north central Canada. Lightning mapper showing significant lightning over Central America once again. We've got some active cells here just moving past Kansas City, I believe. Let's take a look at a real-time lightning map from lightningmaps.org. Give that a minute to connect to lightningmaps.org. There you go. We've got some strong cells north of Tulsa. A rather concentrated series of lightning strikes happening there. Hey, Parsons. Hey, Coffeyville. There's thunder rolling in. Looks like it's calmed down around Kansas City. Could be some cells moving into Chicago there. And that's your real-time lightning map. Keep in mind there are not sensors everywhere, but those are the areas that have sensors and the lightning being sensed. Here's your U.S. Doppler radar map. And before we show the satellite imagery, let's pause once again for station identification. Welcome to the Smash News Network, least busted name in news, where we cite fact after fact and we show forecasts of an appropriate length, 72 hours. Not like 2-week forecasts, which are complete nonsense. Strong storms there, moving into Wisconsin, across northern Missouri into Illinois. It looks like they're calming down, though. A lot of that rain must have fallen already. Heavy rains have just occurred in northern Missouri, also southeastern Iowa. And here's your shortwave radiation map showing clouds and fog. And here's water vapor. And here's your recap. The U.S. Doppler radar. Let's zoom in a little bit on that. Those systems are moving to the northeast. It should be evident on the shortwave radiation map as well. And it'll be even more clear on the water vapor. When your Doppler radar is not giving you the full picture, look at the water vapor. It will clarify things for you in the winter, in the summer, and in all 4 seasons. Thanks for tuning in to the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.